What about the x and y intercepts of a radical equation? Do you think that they exist? Well, we certainly have the ability to find if they exist by simply plugging in 0. For example, if you want to find the y-intercept, you just plug a 0 in for x. Of course, that's always how you find a y-intercept, no matter if you're talking about um, a radical equation or any equation from this year. The nice thing is, of course, when you plug in 0, that usually things cancel out or the math is easy to do. In this case, 0 plus 9 is just 9, and now we're going to try to take the square root of 9. Well, the square root of 9 is really just 3, and so quickly we're going to find 1/3 of 3, which is 1, and after we subtract 4, we get ourselves our y-intercept. We get -3. So that was pretty easy. But if we want to find the x-intercept, now we're plugging 0 in for y, which really means we're setting the equation equal to 0. Now, when you set the equation equal to 0, you find that your goal is to solve for x. So now we have to kind of think like algebra. We have to think like doing some opposite operations, like adding 4 to both sides, like working from the outside of the equation to the inside of the equation. And so, this 1/3 right here, you'll have to multiply by 3 to cancel that. So we're solving the equation for x. Hopefully not too surprised of the two operations we've done, add 4 and multiply by 3. At this point, we have to square both sides because you're trying to undo the square root. And you do get a rather large number. You get 12 squared, which is 144. And once you subtract 9, you end up with 135. Now, 135 is the x-intercept. And that's because we plugged a 0 in for y. Now, we have these 2 points, but it still doesn't change from yesterday that the vertex is still the most important point. Remember, the vertex comes from this idea of shifting, and shifting is what you're actually going to talk about today, because when you have it's what we talked about yesterday, because when you have like a +9, remember that's actually going to shift the graph to the left, and when you have this -4 at the outside, that's going to shift the graph up. So we end up, it's going to shift the graph down. So we're at the vertex of -9, -4. Now, -9, -4, still, as we said, is the most important point. So let's graph that carefully, knowing that that's where this graph is going to start. We do have this y-intercept now of 0, -3. So again, we can graph that carefully. And then we have this x-intercept, which is kind of strange. It's way out here at 135. There's no way that I can actually graph that on the space that you're given, but you can imagine that somewhere way out here is going to be this x-intercept. The whole point is that you're able to still draw a radical graph. A radical graph is a graph that has this slight curve to it, starting at the vertex, passing through the y-intercept, and eventually making its way out to that x-intercept to make the same kind of shape that we had yesterday. Now, this radical graph is very much compressed because 1/3 is going to be pushing down on the graph, and that's why it doesn't appear to have much of a curve to it. But nonetheless, there still is an x and a y-intercept that can be found. Now, you want to try it here for these two problems. I'd like to see you try to plug in 0 and also set the equation equal to 0. You're going to discover that one of the answers for the x or y-intercept for one of these graphs is going to end up being none. It's going to end up being none because you're going to end up trying to take the square root of a negative number. So don't be surprised when you get none for one of these. You'll see that the graph also matches, since the graph would not contain an x or a y-intercept.